Hi everybody, this is Steve. This is another video in the series on how to create generative art. This is the third video about Perlin noise, and this is going to be about Perlin noise flow fields. In the last video, we created this thing. I have simplified it. I'm only using triangles. I narrowed the triangles. It's only in black. So here the only noise is affecting the angle, and this is limiting the angles by 90 degrees. I'm going to take out this floor so that it's not limiting the angle to 90 degrees. And then we'll say we're going to map this to 1 and then make this pi times 2 times the angle. So now imagine that this is the currents in a lake, and you drop something, maybe a leaf, in the middle of that lake. Now the currents are going to take that leaf, and from here it's going to go up here, and then it looks like this one is just going to go straight off the edge. And if it's dropped here, then it goes this way and up and then back this way. So you get the idea. That's what we want to do. We're going to have lines that are following these currents. First we'll do a static flow field, which means there won't be any animating involved. And then later on we'll do an animated flow field. So we're going to have the X and the Y just like we had before, but we're going to have these line segments that start at wherever the X and the Y is, and then they flow around the canvas. There'll be a certain number of line segments. Let's say there are going to be 10 line segments for each line. So we're going to need another for loop. Let's do for I equals 0, I less than 10, I plus plus. And we'll open curly brackets, and we'll put the end of the curly brackets down here. We do not need to do all the translating, so we're going to get rid of that. Get rid of the push and the pop and the translate. And we don't actually need to rotate. We're not going to have a triangle either. So we'll get rid of all that. So the only thing we've got left is the noise and the angle that's calculated. So then before this for loop, let's do an x1 equals to x and a y1 equal to y. That's going to be the starting x and y that comes from here. And this x1, y1 is going to change as our line segment moves across the canvas. And actually, let's change x1 to old x and new x. I think that'll make things more clear. Then we're going to have a new x, and we're going to have a new y. The new x is going to be cosine of the angle, which we already have, times the length of a line segment plus the old x. And we don't have the length of a line segment yet. Let's make it size 2, but the size 2 doesn't need to be the same as it was before. Let's just make it kind of small. So size 1 times 0.2. And let's change this to say len for length. Then we have our new y equals the sine of the angle times the length plus the old y. Now we're going to make a line from the old x, old y, to the new x, new y. And then after that, we need to make the old x equal to the new x and the old y equal to the new y. So the line is going to move, and then the mapping is going to be based on, we've got it based on x and y, but we need this based on old x and old y. Old y. I think we've got everything right. Let me do a little tidy code here, and let me duplicate this Perlin noise flow field. Let's hit go, and we got an error. Old y not defined. Oh, I've got old x. I meant to say old y here. There we go. We got a flow field. So we could do num across instead of 15. Let's do like 40. That's a bit hard to look at. I think we need these line segments to be a bit longer. Let's do the line segments times 1. So that's kind of interesting. I think we want to get rid of our frame. I don't think we need a frame here. Let's put that to 0. Let's try changing the stroke weight a little bit. Make it smaller, 0.6 instead of 1. Let's put num across back to 30, I think. That's looking better. And let's do stroke 0. Maybe put a little alpha in there. I wonder if that would help. That is a little better, I think. Let's do it to 200. Let's change this 0.01. That's interesting. 0.03. Very interesting. And I just realized that my angle is going from 0 to 1. It needs to be going to pi times 2. So I've been screwing that up. Let's try it again. Whoa. Okay, that's because I've upped this quite a lot. Let's do this. There we go. That is so much better. Oh my goodness. Nice. Look at that. I think these line segments could be shorter. Let's do 0.3. Okay, and then maybe make more line segments. Let's do 20. Yes. Very nice. Beautiful. All right, we'll save that. And that is how to do a Perlin noise field static version. Now let's do the animated version. So we'll duplicate that. So for the animation, we know we need something in the draw loop. We also know we're going to need an array to keep track of the locations of all of those different lines. And that means we need to initialize our array with starting position of all of those lines. So we don't need to push the angle into the array because that's always going to be determined by the Perlin noise field. We only need to push the X and the Y into the array. So this is all in setup. We've got the X and the Y. Let's stop here and then we'll close this. Let's see, we're going to have the close of this bracket, the close of that bracket, the close of the setup, and then we're going to have function draw and open curly bracket here. We need an array, so let's put that here. We'll call it lines maybe, equals the new array. And here we'll push lines dot push the X and the Y into the array. And let's tidy that code. Why is that not tidying? Edit, tidy code. Doesn't want to tidy. Oh, it doesn't want to tidy because of this down here. Okay, let's get rid of these. That's interesting that it won't tidy the code. There we go. So we finish pushing all of this into the array. Then we go to the draw loop. We're going to have to go through the length of the array, pull things out of the array. Let's do a for loop here. For, we'll call it j equals 0, j less than the lines dot length, and then j plus equal 2 because there's an X and a Y, so we can skip 1 each time. We'll have an open curly bracket. We can put a curly bracket down here. So we're going to pull stuff from the array. The old X is going to be lines j, and then the old Y is going to be lines j plus 1. We don't want 0 to 20 here. What we really want is maybe a counter. So let's create a counter here. We'll say count equals 0. And then we'll get rid of this and this down here. And at the end of the draw loop, we'll say count plus plus. And then if count is greater than 20, then we'll do no loop. So tidy the code again. We've got our noise from the old X, the old Y. We calculate an angle. We're going to calculate a new X. We're going to make our line. So that all makes sense. We don't actually need to do old x equals new x here. So there's two things we could do. We could either replace the items in this array with the new x, or we could push into a new array and then replace the entire array once we're done. So I think either one works, but let's do pushing into a new array. We'll put the new array, let's say lines 2 equals this. Yeah, that'll work. And then here we do lines 2 dot push new x comma new y. So we're going to push everything. When we get to the end of this, we're going to be done pushing all of this stuff into the new array, lines 2. Then we want to replace the lines array with the lines 2 array. So we say lines equals lines 2. And then we want to make sure that we're not continually pushing stuff into the lines 2 array. So we'll also say lines 2 equals this to empty that array. Does that work? Let's save it, and then we'll hit go and see what happens. Whoa, it worked. Let's give it a little bit of a delay with a for loop that counts to 1,000,000 or so. For z equals 0, z less than 1,000,000, I think that is, z plus plus, and it doesn't really do anything. And we hit go. There we go, a little slower. Let's take out a 0. There we go. That's nice. We hit go and we get another animated flow field. We hit go, another one. So there you got animated flow field. Now this one is limited. We don't continually do the flow field, but we could continually do the flow field. We just would get rid of this count, really. Yeah, we just get rid of this, and I think it would just continually animate, except if we do that, it's going to wind up flowing off the side of the screen, and then it'll be gone. So if we wanted to continually animate, one thing we could do is we could have it wrap around the side of the screen. Another thing we could do is if it goes off the side of the screen, we just create a completely new line somewhere randomly on the screen. I think the random placement of a completely new line is probably going to be better. So let's do that before we push. We need some if statements in here. If new x, if new x is greater than width, then new x equals random width. Let's see. If new x is less than width, okay, we want an or statement in here. Or new x is less than 0. And then we can do another one for y. If new y is greater than the height, or new y is less than 0, then new y equals random height. And then we don't really need the count now, so we'll get rid of this. I think that does it. Let's do another save and hit go. There we go, and it continues. That's interesting. I wonder why there's a line down here like this. I don't know why that's happening. Okay, but it's getting really thick. So let's pause. One thing we can do when we're animating is we can continually add the background. So we've got a background 150. So if we do background 150 each time, let's just see what that looks like. That looks pretty cool. Okay, so what is going on here? I know what I'm doing wrong. I need a new XY location for any of this stuff. That's what's wrong. So I need to get rid of this. Let's see. Pull this out and then say or, yeah, all of this. new x is greater than width, or new x is less than 0, or new y is greater than height, or new y is less than 0, then we get a new x and a new y. That's gonna fix it. Random width. Try that again. There we go. That's better. I want to interrupt for a second. This is Editing Steve in the future. I made a few errors in this video, and I could have edited them all out to make it look like I was programming perfectly, but I leave them in so that you can see that that's a normal part of coding, is troubleshooting errors. And I'm hoping that you'll learn something by watching me work through the problems. So back to the video. But one thing we could do is, instead of completely putting the background there so that all we see are dots moving around, we could have trails by doing the background with some alpha. We could do 150, comma, and we want it to be kind of a small alpha. Let's do 2 and see what that does. There we go. And it's gradually adding the background. Let me put it to 10. So that's the alpha at 10. So that's cool. Let me save that. You remember also a couple of videos back, we did something like this where we used the Z times resolution 1, and we kept changing Z so that it animated the flow field. So we're constantly getting a new flow field. Let's do the same thing with this flow field. So we'll have the noise of Z times res 3, and then we're going to start Z. Let's say here we start Z at 0, or actually let's start Z at 1,000. Oops, we're already using Z here. Let me change this one to just something random. I'll say Q. And then we'll do Z plus equal 2. See what that does for us. And there we go. Oh, wow. Look at that. Lovely. Isn't that beautiful? Oh my goodness. It's like watching starlings. Let's try changing this background. I think if we reduce it to 1, let's see what that does. Lovely. Oh my goodness, that's so good. I was just looking at my notes and I realized there was one other thing I wanted to go over. That is limiting the angles. So we've got our angles right now are going anywhere. So let me change this to 0 to 1. And then we'll have another line that says angle equals angle times pi times 2. I've gone back to the static one, by the way. And that should give us the same thing we had before. But now we want to limit this angle to, let's say we wanted to limit it to 45-degree angles only. Let's do 0 to 8. And then we floor this. So we're going to get a number between 0 and 8, but it's an integer. And then we take that and we multiply by pi times 0.5. No, 0.25. So there should be 8 pi's times 0.25 all the way around. I think that works. Let's try that. There we go. That's what I was looking for. We hit go, go, go. So that's interesting, of course. And let's limit it to, say, 16. And then we could do pi times, that would be 12.5. Let's try that. And not quite as interesting, I think, but you get the idea. Let me copy this. So we've got this that is our old flow field, or you can comment this out, comment these two in, and then you're getting the limited angle flow field. And we could do the same thing with the animated version if we want. All right, I think that's it. This went a lot faster than I thought it would go. All of these art projects are using flow fields, though some of them are not just using Perlin noise flow fields. This circular rotation here is using a different method that I'm not going to go into right now, but just know that there are other ways of doing flow fields. So that is everything I wanted to tell you about Perlin noise. It was a lot. I had to break it up into 3 videos to do it all. In the next video, a new subject, the clip function. If you like the video, give it a like, consider subscribing. Comments, love to read your comments. Consider posting your art on my Discord. Thank you for watching. I'll see you in the next one. Bye.